Domain and range of inverse trig functions. All right, in the previous video, we talked about how these inverse trig functions have issues because at the unit circle, there are infinitely many angles that can output any particular x or y value. So we used this example here. Why should this not be 9 pi over 4 or 7 pi over 4? Both of those have the x value square root 2 over 2. And the answer is because in order for a function to be a function, one input needs to have one output. Input gets one output. It doesn't get two outputs, then it wouldn't be a function. So we end up restricting the range. We restrict the angles that can pop out of these inverse functions. I want to make a note here. Domain talks about the inputs. So domain, these are inputs. And range, these are outputs. So domain is all the values a function can take in. Range is all the values the function can spit out. All right. So the domain of both sine and cosine is going to be -1 to 1. And the reason for that is that what goes into the function, right? The input to this function is an angle, or not an angle. Man, this is a y value. See, well, you'll start to get a little confused when you start talking about trig and inverse trig because they differ by just that -1 sign. And why in the previous video I said you can't say inverse trig outputs an angle enough is because your brain will do exactly what I did, which is call this guy right in here an angle when it's not. So for sine, it's a y value. And the only y values on the unit circle, the y values go from -1 to 1. So those are the possible y values. Any of these points here, the y value will be somewhere between -1 and 1. Now, you might think to yourself, Professor Cook, something seems wrong here. Why is there an x? Is that a typo? Because you said these are y values. You were very clear, but there's an x here and an x here and an x here. And what's going on? Are they x's? Are they y's? And the answer is that this is a function. And with functions, we almost are always using x, right? F of x is equal to sine inverse of x. It does take in y values. The x that I speak of here in this first one, this is y values, but we use the letter x when we're talking about functions almost always as a default. So the possible values that can go in are between -1 and 1. And the values that we as mathematicians have decided will get spit out are the values, the angles between -pi/2 and pi/2. Because if we start here and we end here, we've made sure that every y value between -1 and 1 has a corresponding point somewhere on here. Every angle there, every y value gets covered between -pi/2 and pi/2. And that is including, let's see, that includes the endpoints. So it includes, and you can see that right here with the less than or equal to, it includes -pi/2 and pi/2 because those are possible outputs. If you have sine inverse of 1, this is asking where is the y value 1 between -pi/2 and pi/2? And that would be at pi/2. Sine inverse of 1 is pi/2 because that's the place between -pi/2 and pi/2 that the y value is 1. So we include it because it can be reached. This is a possible output, so it needs to be included in the range. I'm making a big deal about this because tangent is different. For cosine, the input is an x value and the output is an angle. For cosine, we're looking at making sure that all of the x values are accounted for. The way we do that, we start at 0 and we go to pi, and maybe I'll highlight these with like yellow. We go from 0 to pi because all of the x values between -1 and 1 are covered by some angle in that range. And we want to make sure it's only covered once. The domain is the same as sine inverse. Range, again, is 0 to pi instead of -pi/2 to pi/2. Tangent. So as it stands right now, I don't teach graphing of tangent. I just teach sine and cosine. In the future, if I'm still using these videos and I've changed my mind and decided to teach tangent, then this comment will be a little more irrelevant. But for now, we haven't talked about graphing tangent, and I want to talk about how we get inverse tangents range. So right down here, you can see the tangent, just like sine and cosine, is a periodic function, and it has these asymptotes here at odd multiples of pi/2. And the reason for that is that tangent of theta, we define that to be y divided by x. So anywhere where x is 0, there is an asymptote because it's undefined there. Tangent's undefined, and there's an asymptote. So what we try to do here, we want to make it so that all of the possible y values are covered. So y values in the original function become x values in the inverse. X values in the original function become y values in the inverse. We choose this nice little section here. It covers all of the y values, and it just so happens to be between -pi/2 and pi/2. Because right down here, these are the places where x is going to be 0. And what that means is that these are open circles here. You'll notice there's no underline on these guys down here. The range for tangent, the domain for tangent is everything. That these tangent can be any value. It has these asymptotes that go up and down forever. So it can take anything in, but its outputs will only range between -pi/2 and pi/2. So I'd like to do just a couple examples. These are just some of my work from our earlier videos. I'll just erase this. Goodbye. All right. Let's do a couple examples here. So find the values below without using a calculator. So sine inverse of -√2/2. For sine, our range is from -pi/2 to pi/2. Those are the possible angles it can output. And I want to physically write down here what this is asking exactly. So this thing outputs an angle, right? It's going to output some angle theta. So it's asking what angle theta between -pi/2 and pi/2 has a y value, and I'm saying y because we have sine, of -√2/2. Truly, that's what's being asked here. We've limited down our range, so we only have to look here. We know that sine is positive up in quadrant 1, so we're definitely looking at quadrant 4 down here. And we know the √2/2's, those happen at pi/4 angles. So this right here is -pi/4. That's really impossible to read. I'll just write theta. Theta equals -pi/4. If I look at this unit circle up here real quick, do, 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 do. When we talk about the angles between negative pi over 2 and pi over 2, we need to relabel how we think about these guys down here, these angles here. This is really, it's 3 pi over 2, but we're going to think of it as negative pi over 2. That's going backwards, pi over 2. Then this pi over 3 angle, this is actually negative pi over 3 instead of 5 pi over 3. This one is the pi over 4 angle. So this is negative pi over 4, negative pi over 6. It can help to think about it that way. And truly and honestly, we don't care at all what happens on this side over here. Fill it up. Just boop. I don't care what happens over there because, well, we do care actually. Hold on. We care later. We care what goes on in this quadrant, in quadrant 2, when we talk about cosine. We never care about quadrant 3 with inverse trig. But for sine, which is what we're talking about right now, we're only concerned with this. The place where the y value is negative square root 2 over 2 is here at negative pi over 4. And so that ends up being our answer. Theta is equal to negative pi over 4. All right, arc cosine. This is the same thing as cosine inverse, and I like to write it this way. Cosine inverse of negative 1/2. This is going to spit out an angle because inverse trig outputs an angle. Inverse trig outputs an angle. The question being asked is, what angle? Let's see, I'm going to duplicate this. What angle, theta, between, now it's a little bit different, and for cosine inverse, cosine's range is 0 to pi, 0 to pi. So what angle theta between 0 and pi has a, and then cosine is x value, has the x value negative 1/2. Right, so now I don't care about this bottom half. I do care about the top half. That's the part from 0 to pi that I highlighted. We're asking, where is the x value negative 1/2? Right here at 2 pi over 3. So theta, let's see, it's 2 pi over 3 somewhere up here-ish. Theta is equal to 2 pi over 3. All right. Tan inverse of 1. Let's come on to this unit circle real quick. And somewhere you should have a unit circle around that you've been writing on, or you can write on this one, but let's make note of the tangent values real quickly. So remember, tangent for the unit circle is equal to y divided by x. And then there's a lot of symmetry that happens here. I'm going to make this guy. That's fine. All right. So here for pi over 6, we have the y value divided by the x value. So that's 1/2 divided by square root 3 over 2. Just kind of quick math, just a refresher. With a complex fraction, you can multiply the numerator and the denominator by 2 on the big fraction. Those will cancel. You get 1 over square root 3, which I'm fine with it being, with the denominator not being rational, but because this is a special angle and it gets talked about a lot, people talk about it in its rationalized form, which is square root 3 over 3. So the tangent value here, can I make this smaller? Make you smaller. The tangent value here is square root 3 over 3. Tangent, if you think about all students take calculus, tangent is positive in 1 and 3, and then negative in 2 and 4. So I'm going to look at all the pi over 6 angles. This 5 pi over 6, this is going to be negative square root 3 over 3 because it's tangent's negative in quadrant 2. 7 pi over 6, this one will be positive square root 3 over 3. And over here, this will be negative. Let's move that. Negative square root 3 over 3. The pi over 4 angles are easy. Square root 2 over 2 divided by square root 2 over 2. You're dividing something by itself. It's just 1. So negative 1 for quadrant 2, positive 1 for quadrant 3, negative 1 for quadrant 4. For the pi over 3 angles, you have square root of 3 over 2 divided by 1/2. Oh, so messy here. Multiply by 2 on top and bottom. The 2's cancel. You get square root of 3 over 1, which is just square root of 3. Negative square root of 3 for the 2 pi over 3. Positive square root of 3 for 4 pi over 3. Negative square root of 3 for negative, or for 4 pi over 5 pi over 3. Last but not least, we have these like the north, south, east, and wests, right? For 0, this is going to be 0 divided by 1. 0 divided by 1 is 0. And on the other side over here, 0 divided by negative 1 is 0. On the top and the bottom, you get 1 divided by 0, which is undefined. And down here, you get undefined. Again, because you have the y value, negative 1, divided by the x value, 0. And what I'm going to do here is, not that. I'm going to just highlight these because they're the tangent values. It can really help to have these sitting around so that you're not deriving them each time. Okay. Fun. Okay. So again, tangent, back to where we were. Tangent, inverse tangent has the range of negative pi over 2 to pi over 2. We're asking, where is it 1? So for tangent, I wonder if I can like bring this layer up to the top. Huh. What a miracle. All right, there we go. So where between negative pi over 2 and pi over 2 is tangent equal to 1? It's here at the pi over 4. You may think, I don't need to write that down. I don't need to write that down. There's a reason I'm writing it down each time. First of all, it's that I hope that you're writing this down. And it's because the more you can write this down, the more your brain is going to de-abstractify the concept that we're talking about here. And at the end of the day, this is a fairly abstract concept that's going to make a lot of sense when you're sitting down and working with it. But when you step away from it and come back to it, it's going to feel hazy again. These types of notes in your notebook will help you a lot when you try to recall this topic later. And we found that this is at pi over 4, right? So theta is equal to pi over 4. Finally, we have arc sine of 0. This is just sine inverse of 0. Again, this outputs an angle. So we're asking what angle theta between, and let's highlight it, negative pi over 2 and pi over 2. Is the y value 0? The y value is going to be 0 right here, and it's at theta equal to 0. And you can look right here, y value, the one place where the y value is 0. All right, so that's that for this particular video. In the next video, we're going to talk about composition of trig and inverse trig. So quick preview down here. Questions that look a little bit like this. I'll see you in that next video. Bye.